I wonder what the derivative of sine is. Now, here's the deal. It's not a polynomial to where we could just say, oh, coefficient times exponent, subtract 1 from the exponent. It's not that easy. But we can use the limit definition of a derivative. What's that? Glad you asked. It is this right here. So the limit as h approaches 0, this will look very familiar. It's f of x plus h minus f of x over h. That's what we're going to do with this to figure out the value of the, or figure out the derivative of sine. And you'll be surprised when you get to the end of it. So f of x plus h is really sine of, well, x plus h. Okay, sine of x plus h, well, what is that and what can I do with that? Well, there are some things that if you're following along on notes that you'll see that we can actually take this, run with the idea just a little bit by expanding it some. And it is this. There's a little thing on the notes that says sine of alpha plus beta equals, and then it goes through this whole thing. But instead of alpha and beta, we're going to use x and h. So it goes a little bit further, and it is going to be sine of x cosine of h. All right, and I want to pause right here. Cosine h, it actually is a mathematical symbol, or is an operation. It's called hyperbolic cosine. And the same thing is actually going to happen in a second with sine of h. It's going to look like hyperbolic sine. That is not it. That's not what we're dealing with. That is not in the AP Calculus curriculum. If this was truly hyperbolic cosine, we would have another thing here, another argument that we're taking the hyperbolic cosine of. That had nothing to do with anything, but I don't want someone to look at this and be like, what's this hyperbolic cosine? It's not happening, okay? Just saying, wow. Long explanation just to tell you that there's nothing going on here. Sine h, not hyperbolic sine. Different way of computing things in different type of space. Okay, back on topic. Here's what we're gonna do. We're going to take this and plug it in there, subtract sine of x, and then eventually figure out what the derivative is. So the derivative of sine is about to pop up as we continue this process, hopefully with a marker that will last us through the rest of the problem. So continuing with what we have in blue, we have the limit as h approaches 0 of f of x plus h. That would be this, which is really all this stuff. So let's write it. Sine, my head's in the way, you'll be all right. Sine x cosine of h. You may want to put parentheses around it so it doesn't look like hyperbolic cosine. Cosine of x, sine of h, parentheses if you want to, minus sine of x, all divided by h. Okay, plugging in 0 for h is not going to happen. Good luck with that. Nope, not going to happen. I'm going to run out of space if I keep going down this way. I'm going to bring it over here. So all my blue stuff is going to come over here, and we're going to have the limit as h approaches 0. Of what? Well, okay, I'm going to stretch this out a few extra steps. We're going to rearrange a few things and kind of go from there. And you'll see where this is headed in just a minute. Okay, so I'm going to put this term first, then this term second, and this term third. Why? You'll see where it's going. Sometimes you just experiment to find where this stuff is going. So sine of x, cosine of h, minus sine of x, plus cosine of x, sine of h, all over h. Will you be expected to do this on the final exam, on the AP exam? I hope so. No, never seen it. That's a shame too, because it sure is a lot of fun. But it's a good process to learn just a little bit of extra trig stuff. Apparently they want to say something, but I'm just going to keep talking. Okay, let's take these first two terms and we're going to factor out a sine. Why? Because you can. Sometimes you just do stuff and you run with it, kind of like someone's messing with the internet. Like they're messing with the internet. So we're going to factor out a sine from these first two terms. And when we do have sine x, and then we'll have cosine of h minus 1. And then we'll have plus cosine of x sine of h, all divided by h. Okay, all right, let's keep going. we've got some stuff going on here that we need to deal with, and I think we can break this up into two separate limits at this point. Actually, we can break it up into multiple limits. Limit h approaches 0. So if you're watching this video, well, which you are obviously are watching this video if you're hearing this, the intercom, the intercom system had gone out, and so they're trying to fix it while I'm recording this video. They didn't ask me, but it's all good. So we're going to have sine of x cosine of h minus 1 over h. So here's what I'm really doing. I'm going to take this stuff right here that you may or may not have thought to do, and it's okay if you didn't think of it. But I'm going somewhere with this, and when we go somewhere with this, you're going to say, oh, this is going to really start making sense. Trust me. As we go somewhere with this, it's going to start looking like some things that you have seen before. And one of the things that you've seen before, and I'm going to hold up the paper, is this. And another one you've seen before is this, right? And so we're going to just kind of take those two ideas and we're going to run with them, because I'm really aiming for those kinds of things. Okay, so all this is over h. And then we have this other thing where I could just put this over h separately. So plus the limit as h approaches 0 of cosine x sine h over h. Okay? And we've broken this up into separate limits. And I'm going to continue to break it up even further. So I'm going to say that we have the limit as h approaches 0 of sine x over h, and then cosine h minus 1 over h. Let me rephrase that. Let me fix what I just said. Let's rearrange this. So this is the limit as h approaches 0 of sine x. Using the properties of limits here, I'm just saying, well, let's multiply sine x, and then we'll multiply with this. So we'll have the limit as h approaches 0, because I'd said it accidentally wrong earlier, which would have been a great time for them to come on the intercom, but no, they won't do it when I say something wrong. There we go, there's that. And then plus, and then we're going to break this one up into separate pieces too. We'll have the stuff that has just the x's, and then we'll have the stuff that has the h's. And breaking it up into, I'll say breaking it up, I'm factoring it into two separate pieces. The things that have x's, the things that have h's. So it's the limit as h approaches 0 of cosine of x, and the limit as h approaches 0 of sine h over h. Okay, we're going to use some of the things that we know, that we have seen before, to figure this out. So I'm going to actually start on this end and work my way backwards. Limit as h approaches 0 of sine h over h. You've seen it before, but we used x's instead. And this little guy right here is equal to 1. Okay? So that's 1. Fantastic. This little guy, h approaches 0 for cosine of x. Well, there's no h in there, so we're just left with cosine of x times 1. Okay, still good. Plus. Okay, let's back up here. This is looking like what you see on the top of your paper, only it's reversed. But it's okay. If I wanted to, I could say that this is really negative, and then parentheses, cosine, oops, 1 minus cosine of h. I could do it that way, factor out a negative 1, and then I really could say the negative goes in the front here. But at the end of the day, the whole thing is going to be 0, because we have the limit as h approaches 0 of 1 minus cosine h over h, or cosine h minus 1 over h. Either way, you're going to get just 0. So this doesn't even really matter. So this would be sine x normally, but it's sine x times 0. So we have 0 plus cosine times 1, so cosine. The derivative of sine is cosine.